We will continue our discussion on the defects in rotating machines. In the previous classes, we talked about balancing and imbalance, and how we can remove imbalance or unbalance by balancing the rotor shafts. And then another very important fault or very commonly occurring fault is misalignment. Sometimes in real world it becomes very difficult to distinguish between misalignment and unbalance also, but nevertheless misalignment, there are many reasons why misalignment occur, and I will come to that just a little bit. And as I was telling you, in the laboratory we have this rig wherein we created artificial misalignment by introducing shims on the base. Okay. So, what is this misalignment and so on? See, ideally, as I was telling you before, in all these machines which we are talking about, there is a prime mover, okay, and which is driving a mechanical unit. And this prime mover is actually on a foundation, and similarly the driven unit is also on a foundation. And mind you, these machines can be very, very large. I just gave you an example of the cement plant. This could be a large cement kiln driven unit. So, ideally, if a shaft, both the shafts, I am just drawing the center line as a shaft, they have to be in a single straight line. So, if we rotate, there are no forces because of either what is known as a parallel misalignment. So, this is what is known as the offset. So, shaft 1, shaft 2. So, this is what I mean by a parallel or misalignment. Why did this happen? Maybe this was at a different position along this direction. So, along y direction perhaps this was shifted, or along z direction, and so on. So, this happens, misalignment happens because when you are installing large machines, these foundations have to be almost very straight line, smooth, because of little defect in the construction, and these tolerances could be order of few millimeters, less than a millimeter. Okay. So, that again brings about, these are all rigid machines, and we have bearings here, they are all very rigid bearings supporting these systems. So, this kind of problem may occur, and they could be very heavy. Okay. Heavy machines. So, we have to physically ensure by putting some caring for this height differences by what is known as putting shims. Shims are nothing but very hardened steel plates, okay, which can take good amount of load, and they can make up for these gaps. If this has gone up, I can put shims at the foot of this machine and raise this shaft so that they are aligned. Now, how much to put, where to put is something which we will physically do it, and this problems occur because of many things. Usually, once you are installing heavy machines, it is defects or during installation. Okay. Nowadays, people use laser for alignment. There are again commercial companies who will align the systems, and I am sure those of you who have taken your automobile to the daily car servicing stations, they will do a wheel balancing, they will do an tire alignment or wheel alignment. only to ensure that there is uniform wear and tear in the tires. And then another misalignment is this angular misalignment. Okay. They are at an angle, some angle. So, continuing our discussions, another could be this corrosion of shims or foundation frames. Another could be soft foot, okay, sinking, looseness at foundation. Well, I am not going to teach you about foundation design, but you know how a good foundation design has to be done, and then how vibration isolation has to be done, and so on. So, these are all possible reasons why misalignment can occur. Okay. And I know of a case where in a very close to the sea, the atmosphere is salty, corrosive, and these channels are available. Okay. Frames made out of channels, and onto this the machines are put with proper foundation bolts and so on. Imagine, and then they are resting, etc. I know of a case where an equipment were brought to the shore because there was a port where there is a lot of material handling equipment in terms of motors, gearboxes, driving idler, pulleys for the conveyor systems. It was a new plant, but as soon as the conveyor system started operating, they made excessive vibrations. On close examinations, we measured the vibrations. On close examinations, we observed that these shims, these foundations had corroded. Okay. And during installation, whatever shims were put, they corroded with time, and so usually painting is done. Anti-corrosive paintings are done to avoid such excessive wear and tear and so on. So, what are the factors affecting misalignment? This misalignment can get increasingly high if the machine speed is increased. The coupling, which is supposed to take away all the misalignments, if there is a small amount of misalignments, these couplings can take them away. For example, you would have heard of, I will come to the coupling in a little bit. Okay. So, what happens? The effects of misalignment is additional forces and moments at the bearing locations. Okay. Additional, obviously, if there are additional forces and moments, there will be additional power consumption because the frictional normal forces have increased. So, the frictional forces would have increased, and additional power consumptions to overcome these frictional forces. Obviously, fatigue load of the system and premature failure of the system and components. So, how can minor misalignment be mitigated? One is to have flexible coupling, and you would have seen in all these machines which are driven by motors, there are flexible couplings. Okay. The helical couplings and so on, gear couplings, etc. But another, in automobile, we have a shaft or an engine here and a differential here. So, there is a large angular deflection. Okay. So, they put what is known as a Hooke's joint. because the angular deflections or the angle of the two shafts are very, very high. But I am not talking about this kind of coupling, but small flexible couplings can be used. But despite having the couplings, there is a strong presence of misalignment. So, alignment is checked by measurements and leveling is done by introducing shims, and shims can have their own problem. So, during installation for large machines, you can always what is going to happen because of misalignment is 3 o'clock, 6 o'clock, and then the 9 o'clock, and this is 12 o'clock. Okay, this nomenclature is followed in the military, and we also follow it here. 3 o'clock means looking at the watch, 3 o'clock means this position, and so on. So, if the shaft is rotating in a circle, the distance which it moves is the radial run out. So, radial run out, if it is same in all the three directions or all the four directions, that means the shaft is concentric with the housing. Okay. So, if shafts at both the ends are checked for the radial run out, and if they are the same, you can say for certainty that the shafts are aligned. Okay. Otherwise, you have to move shims on either of these locations so that they are aligned. Okay. And vibration measurements at the inboard and outboard bearing locations. So, you can measure the vibrations and then you can find out. So, but then from a vibration monitoring point of view, how do you detect misalignment? And that is very important. As you would have seen in a shaft system, if the shafts are misaligned, okay, there will be when they are rotating, there will be a strong axial pull push effect. Intuitively, you can think shaft are rotating like a cone, pulling, pushing. So, this gives rise to high axial vibrations. In one of the earlier classes, I had mentioned you that this is the axial direction or the longitudinal direction, and these are the radial direction. It's my horizontal, vertical, and this is my radial plane, and this is my axial. So, usually the axial vibrations V axial is higher than V radial, and this is a sure case of letting you know that a misalignment has occurred. And usually, if you look at the rotational speed being 1x, usually high vibration occurs at 2x. So, 2x vibration with a strong axial vibration compared to the radial plane is a sure indicator of misalignment in the systems. But out of my practical experience, I must tell you that whenever we have a machinery with misalignment, okay, it will lead, and if this was neglected, this becomes difficult to sometimes identify because of bearing defects, because of unbalance, etc., and so on. So, one has to keep in mind. So, the best way is to look into the case vibration for the case of a misalignment. This was a shaft which was rotating, and then I can see very strong 2x component here, okay, and this is one axial vibration for the misalignment case. But question is, I very crudely told you that we can measure the method by measuring the vibrations at 12 o'clock position, 3 o'clock position, 6 o'clock and 9 o'clock. Okay, and by measuring the vibrations, we can see whether there is a strong axial component. I would be confirming that it is the case of misalignment. But later on we will see, when we talk about misalignment, there will be forces coming, additional forces coming to the coupling, and this will also give some forces to the bearings. The forces to the bearings increase, the frictional forces at bearings increase. So, this leads to increase in heat generation at the bearings. So, later on when we discuss a technique called thermal imaging by what is known as infrared waves, which is known as thermography. In fact, our research group has found out that if you, with time, if there is a misalignment, the temperature rise at the bearings. If it is a misalignment case, the rise is more compared, the rate of rise is more, and this is my equilibrium. So, this is the rate of rise. The slope here is much higher than this. This is there for the normal case. And this is for the misaligned case. And this happens within the order, first order, the time constant of the system, and this could be as for typical cases within the time constant of the system, the temperature rise. So, you will see later on, by monitoring rate of temperature rise in bearings, sometimes in couplings, misalignment can be detected. Now, obviously, because they are rotating systems, I cannot use the conventional measuring devices like a thermocouple. So, a non-contact temperature measurement device like a IR camera can be used. And this example, by the way, we have a reference, our research work on this is available, and you can find me in my Google Scholar citation. You can find this paper, or you can go to my website www.ircamera.com. iitnoise.com to see the details about this in a journal paper, on an IMechE journal paper, where our group was the first to detect the presence of misalignment in a rotating shaft system by measuring the rate of temperature rise through an infrared camera. And this has a lot of significances now. Imagine the challenge which we have today is, I was mentioning about wind turbines. Wind turbines are being put to use energy as alternate source of energy and then there has been a lot of use of this wind turbines. But you see, these wind turbines are put on trestles very high from the ground, and this could be as high as 100 meters. And then we have this turbine, large fan, and there is the gearbox, and then all those devices they are there, and then we have a generator, etc. And physically, to measure any defects in this gearbox or the generator, of course, you will see another new technique which I am going to discuss later on is MCSA. I am just giving you some new topics to browse and get excited about, and which we are going to discuss about later on. Another is thermography, because eventually we will see by now that we are using a lot of vibration monitoring techniques for detection of faults in system like imbalance or misalignment. But now with research being continued or carried out throughout the world, a lot of new technologies have come up, one being motor current signature analysis, other being thermography. Now imagine if you have a drone with an IR camera, and if this drone goes up with an infrared camera, you can measure the temperature of these bearings and acquire it quickly, and then see this rate of rise, and that will be a very easy way to detect misalignment in a large place where conventional vibration monitoring would be difficult. For example, one is the site, and if you go to the North Sea, they are all anchored to the ocean bed. So these are challenges to us to find out misalignment in rotating systems. And you know the consequences of having misaligned axles in railway coaches or locomotives. It can lead to derailment, etc. So misalignment would lead to bearing heating, coupling heating. If you have better techniques of detecting bearing heating or coupling heating, we can find out misalignment in such systems. So reverse indicator method, if you notice this, we have dial gauges just to measure x and y on the rim of these machines, and these are dimensions A, B, C, D, E. So all you have to measure is dimensions A, B, C, D, E. So the reverse indicator method procedure is like this: 0 the dial indicators at the 12 o'clock position, slowly rotate the shaft and bracket arrangement through 90° and record the readings at the 3, 6 and 9 o'clock locations. Calculate the movements in the horizontal and vertical directions at the foundation locations of the driver and driven unit. Apply or remove shims of appropriate thickness at the foundation locations. So we can measure the movement at location y 1, 2, 3, 4, where x is 1/2 of the driver rim reading difference from top to bottom or side to side, and y is 1/2 of the driven rim reading difference from top to bottom or side to side. Return to the 12 o'clock and check 12 o'clock position to check if the dial indicates 0. Repeat the above steps if required. So, this is a process people do to do the removal of misalignment when they are installing machines, and this could be measured by dial gauge, but only thing is that if these are large systems, they are rotated slowly by hand. So, usually any misalignments are actually today, of course, we have laser based systems. Suppose this is a shaft and there is another shaft. Okay, if I am shooting a laser beam, if the laser beam goes out, okay, if they are misaligned, they are aligned, the laser beam goes out like this, it will come out this way, laser beam goes out like this, it will come out this way. Okay. And then what happens is, if you look at the mirror here, there will be two dots, one going like this and one, and there they have put reflective mirror. Okay. But if they are misalignment, the reflection of the laser beam would come at a different spot. So, this such laser based systems are commercially available. To do the alignments in such systems. Okay. And this is again out of my book, so you can get the details in this book. Thank you.